Greetings. I'm Dave White, Chief of the Natural Resources Conservation Service. 70% of the land in the lower 48 states is privately owned. That's why working in partnership with landowners is key to any effort to preserve the health of our environment and the sustainability of our natural resources. At NRCS, our mission is to help farmers and landowners make conservation work on their lands. We introduce proven conservation practices to help reduce agriculture's environmental impact and increase its long-term health and productivity. A crucial piece of our work is protecting water resources by helping farmers minimize sediment and nutrient loss. There are several conservation measures that are being put into practice every day to preserve water quality, and new ones that are still being developed. In this video, you'll hear from farmers, academic professors, and other experts about some of these management practices and the results they're seeing in the field. Let's start with a look at what's happening at an agricultural research facility in southwestern Minnesota.
We'll head over to our nutrient basins, our wetlands, and then our drainage ditch site. We're going to talk about things that are in the field, that are at the edge of the field, that are in stream. Research and Outreach Center here at Lamberton has had a long history of doing water quality types of research. It's going to emphasize the whole suite of what I consider drainage water management. We're looking at different technologies, and that's what we do at our drainage field day. We focus on work that we're doing here in Minnesota and our neighboring states, bring in the top researchers who are doing the work.
The farmers and the farm communities, they're the cradle of innovation, and they are the ones that are going to figure out the ways to grow food without making our water dirty. And we need to help support them as taxpayers and as consumers.
We're very dependent as a society worldwide on the food that's produced in the Minnesota River Basin. Into the Red River Valley, there's what I would call the modern day Fertile Crescent.
We have corn, soybeans, and then we harvest about 300 acres of the grass. My dad was very proactive putting in waterways and some terraces. We've got some buffer strips along the rivers.
You may just have a grassed perennial buffer, or you may have a forested buffer.
In the past 20 years, conservation tillage has become very important to keep the soil on the land. When you keep a lot of residue on the land, just like mulch in your yard, it will keep your soil more moist.
Using different types of tillage, we're able to hold the soil throughout the winter and the spring much better.
And so with conservation tillage, there's become a greater demand to tile your land out.
Our goal is to have every field pattern tiled.
If farmers are not allowed to use their drainage systems, when I say drainage systems, not just surface tile, but also their ditches, I would guess that corn and soybean production would drop by 40% overnight. The problem with that is sometimes we move too much water.
My dad said that we need to be able to shut off the drainage because in this area we get into August and it can get very dry.
What if we were able to maintain more soil water in the profile at those times? This is kind of in the summer conservation mode, but this structure has a set of baffles, stop logs, boards, whatever you want to call them, weir boards, in the middle that you can raise and lower, so you can stack more in here and cause that water table to be even shallower before it leaves the field. Or you can take them all out and put it in that traditional drainage mode.
This is Jeff.
I contacted Jeff Strock. I think I've got a place where we could manage the tile. In 2005, we installed the drainage system in that field with the two control structures.
This is a water control structure. This structure gives us the opportunity to manage that soil water instead of just discharging it like it was sort of a waste product.
When fertilizer is costing me close to $200 an acre, I don't want to share it with anybody. So through the managed drainage, we're able to keep back nutrients that would normally go out through the tile lines. This field right here in the middle of the poster is the field that we conducted the drainage research on. This portion of the field is managed in conventional drainage mode where the tile is allowed to flow continuously all year round. This part of the field is managed in controlled drainage where we actually open and close these gates to allow water to leave or to conserve water.
We monitor drainage flow, so we look at the amount of water that comes out. We look at the nitrogen as nitrate mainly, and we look at phosphorus. You know, on average, it's probably about 50% reductions in nitrogen and phosphorus. We also see pretty close to a 60% reduction in actual drain volume. We're holding the water back. The nutrients that are dissolved in the water are not leaving the site. You know, from year to year, we don't always get a yield benefit. But there are years where we may see a yield benefit. 2009, the controlled drainage side of the field averaged 223 bushels. The conventional side of the field yielded 202. We actually got a 10% yield increase.
This afternoon, we're going to go out to Russ Derrick's and farm just south area. He's going to be installing a control structure out there.
This is a 6-inch structure. We put 6-inch PVC on each side. For the first part of it, you want to use non-perforated so that the water doesn't try and bypass. We use the rock base underneath just to help stabilize it, and then we will backfill it up to grade and put a marker by it so that it doesn't, hopefully, not get hit.
When you set an elevation with your top stop log, when it rains, it still drains. We always recommend that you manage as cautiously as you think you need to conserve and protect your crop.
After we'll get the harvest off, we'll put the stop logs in, and we'll probably hold it within 2 feet of the surface all through winter. And then about a week and a half, 2 weeks before we think we're going to plant, I will pull the stop logs and we'll let the profile drain out. And we'll be able to work the soil, plant it, and then we'll put the stop logs back in.
When I design these systems, I like to use no more than a foot difference in elevation before when you set the structures in.
If you want to add structures and you're careful enough with your design, you can apply it to steeper ground. It might not make sense, so everybody starts with the flatter ground first.
The challenge with any of these practices is initially, it's some of the fear of the unknown.
It's a completely different mindset to drainage when you're trying to lay out a field to be able to control it.
So controlled drainage has been adopted more where people can see it fitting in their landscape and they say, that's going to work for me, and they go to their SWCD offices and they're asking about it.
We have a field set up for drainage water management, and we can basically feed water back into the system and raise the water table.
And we can actually pump water from a well, a river, a pond to do sub-irrigation. And this year we actually sub-irrigated one zone in Bryan's field. And so we'll see how that turns out.
So you can add an outside water source and maintain at whatever level you set the stop logs at. If you had all the systems connected together, you could put water into the top, if you had a well there, and it would fill that one up. The overflow would fill the next section and fill the next section, so you could basically irrigate the whole field with that.
Vastly less water than any other type of irrigation.
Now we have 3 different pairs of basins. The wetlands are storage basins. You're trying to find a place where you can slow the water down a little bit, get some treatment. We've got a surface flow system, so it has a permanent pool of water. The horizontal flow system essentially is designed kind of like the bioreactor or a municipal wastewater system. The next pair are what we call our vertical flow systems, and we force the water from the drainage, and it has to filter through the soil itself. We've made some reductions, somewhere on the order of anywhere from 25 to 50% reductions in the nitrogen and the phosphorus that have been coming out of these systems.
This is the pond my dad put in 1973. This was a big ravine. We made an earthen dike, and it catches all the silt and everything before it hits the river.
In picking sites, that's definitely something to look at.
And I was at a meeting Leonard Binstock put on about biodigesters and ways that tile lines were going to be changing for better production. They're taking out the old tile into a control structure, which will then push the water into the wood chips in this digester.
It's a relatively simple concept, capturing water from tile lines long enough so that it breaks down nutrients before it gets discharged to the stream.
The use of a bioreactor has so many advantages in the removal of the nutrients, the phosphorus, the nitrates that do percolate through the ground.
In Minnesota, we've got about 27,000 miles of drainage ditch. It's the last line of defense before the water leaves
the farm fields before it gets into the rivers and streams.
Does it make sense to over widen the ditch? Is there some profitability in doing that in terms of reducing the amount of clean out time?
So we have a low flow, narrow channel, and then we actually develop a floodplain within the ditch.
It's that interaction with that active floodplain that provides some nutrient attenuation.
Now there's another style called a natural forming channel. The ditch is over widened, say from 5 feet to 10 or 15 feet wide, and then it's just left. The flowing water will find the path of least resistance, and it will create its own low flow channel and its own benches.
Instead of letting that tile water drop right into the bottom of the channel, we're running it along a formed linear type of treatment system.
We can see 75% reduction in the nitrogen during a low flow period.
In terms of just the maintenance, just the management of clean out, there are certain ditches that are going to be cost effective to do this on.
There are definitely some practices that have some potential for increasing crop productivity. Then we can maybe make a bit of a difference in at least some of the water quality issues.
We're living in exciting times. I mean, 15, 20, 25 years from now, we'll have solved a lot of these problems because we've recognized them and we've moved beyond denial of things, and we're working together more often now. Some of our best allies are in the agricultural community.
The farmer can't do it all on his own. Don't be afraid to step up and be an advocate or be a partner, help it out. We're all going to benefit from it. It's just not a one-person show. It has to be everybody working together.
The ultimate goal is to take that knowledge and transfer it to growers, transfer it to the dealer supplier industry, to the state agencies, to incorporate that information into best management practices. And so that's why we kind of work together. MDA, PCA, Army Corps, the drainage people, the soils types of people, the corn growers groups, and that. Yeah, it's a matter of working together, because that's the future.
As you have just seen, conservation practices are being implemented every day to help curb the loss of nutrients and pollutants into our waterways. We know conservation works. Through these practices, we are reducing agriculture's impact on the environment while also helping farmers increase productivity on their lands. A report released by NRCS just last year showed that nitrogen losses in surface waters have been reduced by 46% in the upper Mississippi River Basin, thanks to proven conservation measures. But there's more work to be done. The report also showed nitrogen losses in subsurface waters have only been reduced by 5%. More conservation planning and increased management of ag drainage water is needed to continue to improve our nation's water quality. Through continued collaboration and partnerships with farmers, landowners, the private sector, and government entities, we can help ensure cleaner water and a healthy environment for the public, for wildlife, and for those millions of little Americans that will come after us. Thank you.
It's time we all understand that it's what we do on land that makes our water what it is today. This simple fact is true. It's controlled by me and you. It's time to fix the mistakes of yesterday.